In episode 16 of our CySec101 training series, we're going to go through networking core protocols. And this is a part of the Cybersecurity 101 pathway of TryHackMe. And we're just continuing down with our networking module here. We've done 2 rooms, I believe. So we did networking concepts and we did networking main components, or what was it called? Something along those lines, where we did the general networking concepts, and then we did the networking essentials. There we go. So we did networking concepts, we did networking essentials, and then today we're going through the core protocols in networking. And this episode has been brought to you by the Hackaholics Anonymous membership community, which is the premier YouTube community for security professionals and hackers. And you get access to 4 tiers of benefits. It starts with the cyber supporter that gets their own Discord server, as well as direct access to me and all of our advanced members, early access to content, so on and so forth. And then we have the advanced memberships, the cyber agents, guardians, and the masters, where they get access to Python automations every single month. They get access to live streams with me, exclusive content, exclusive downloads like the documents and the notes and the practice examinations and questions for the Security Plus that is coming up. So if you wanted to join Hackaholics Anonymous, you would access the link in the description below, or you can go to our homepage on the channel and click join, or you can simply go to youtube.com/@hankhackshackers/join, and you'd be able to go to our join page for Hackaholics Anonymous. Now, without further ado, let us jump into the introduction for network core or networking core protocols. All right, this is the 3rd room in the series of 4 rooms about computer networking. We've already done concepts and essentials, and we are going through core protocols today. And then there's going to be the secure protocols. That'll be the next thing that's going to come up. The prerequisites for this video and for this room is to just understand the various layers of the ISO OSI model, as well as the TCP IP model. I think we'll probably touch on it very briefly, but if we don't, it would be very beneficial for you to know what those things are. And you can very easily just Google ISO OSI model, and then even the TCP IP model, and then just go to Google Images, and you'll get a really nice cheat sheet, from 100,000 different locations, where it would just break these things down for you in a variety of details. So we have Ethernet, IP, and TCP protocols, which are the big things that we're going to be talking about, since we're going to be talking about the core protocols in networking today. So if you have not gone through the basic networking concepts, this is the recommended approach for you to take. You should, at the very least, understand what the TCP IP model looks like, and what the ISO OSI models look like, so that the rest of this stuff will make sense to you. We're also going to be running some basic commands through the virtual machine that we have for this room, as well as the attack box. And we're going to be learning about these protocols in particular, which is the WHOIS protocol, the domain name system, HTTP and FTP, SMTP, POP3, and IMAP. I've already started the machines, and the attack box is all running as well. So everything's all good, ready for us to go. So we are about to jump into the very first one, which is DNS. All right, chances are that you are like me in the sense that you are not Rain Man and you don't remember numbers extremely well. Meaning, maybe you do remember numbers, right? So let me rephrase that. I'm pretty good with numbers. I'm decent with numbers, but I don't remember the IP address for YouTube, or the IP address for Google, or the IP address for Gmail, or the IP address for Facebook. I don't remember these addresses. And if we had to remember the addresses of the favorite websites that we go to all the time, especially considering the fact that their IP addresses are actually dynamic, they're rotating in and out. So they don't even keep the same IP addresses for security purposes. So if we had to remember all of those IP addresses, it's probably very likely that we would go to like some kind of IP address book, so to speak, where you have a contacts list and you reference those IP, because we just won't remember all of these numbers. There are billions of domain names online, and it's just impossible to remember all of them, again, unless like you are a whiz with numbers. So the DNS, the domain name system, is where that becomes a little bit more convenient for the layman, for the average person like me, right? I don't know that the IP address for Google is whatever it is, but I do know google.com, and I do know facebook.com, and I do know Gmail, and you know, fill in the blank for your favorite domain. So it's like I know these locations by name, but I don't know their addresses. And that is where the domain name system really just kind of flexes its power. It's responsible for properly mapping a domain name to an IP address. That's what the DNS protocol and the DNS system is really all about. It operates at the application layer, which is layer 7 of the ISO OSI model, and it is also, I guess, layer 1 or layer 4 of the TCP/IP model. I don't know, because they flipped it upside. It's confusing. You know, all I know is that ISO OSI has 7 layers and TCP/IP has 4 layers, and some of the layers from the ISO model have been crammed into one layer. For example, we have the application, the presentation, and the session layers from the ISO model that has been all crammed into the application layer of the TCP/IP model. That's basically all I know. and of course, I know the various layers. It's just that the order of them is always confusing. I have a little bit of dyslexia, but whatever, it's all good. So DNS traffic uses the UDP port 53 by default and TCP port 53 as a default fallback. There are many types of DNS records. However, in this task, we are going to be focusing on these specific records. Now, if you've ever set up a website, then you should be familiar with these things. If you've ever set up, if you've ever bought a domain name and set up hosting, these things should actually be very familiar too, because for each domain name, there needs to be an A record, a quadruple A record, a CNAME record, and an MX record. So the A record, which is the address record, maps the host name to one or more IPv4 addresses. For example, example.com will go to this IP address. The quad A record is similar to the A record, but it's for IPv6. So remember that it's quad A, so quadruple A. And AA and AAA would refer to battery sizes. So furthermore, AAA refers to authentication, authorization, and accounting. Neither of them fall under DNS. So this is just extra information to confuse you a little bit. What's important is to understand that quad A, quadruple A, is the record for IP address, IPv6 addresses, and then the A record, the address record, is the IPv4 addresses. And then you have the CNAME record, which is the canonical name, and it maps a domain name to another domain name. So for example, example.com can be mapped to example.com without the wwws right here. So www.example.com can be mapped to example.com without the W's, or even example.org, right? So it's the canonical name, which basically maps the domain name to another domain name or other versions of it. So just in case somebody doesn't put the www and they just do example.com, they'll still be taken to the website. And if they do example.org, if you've purchased example.org, then you can also just redirect it so it goes to your main website, your main domain name. Then there's the MX record, which is the mail exchange record that specifies the mail server responsible for handling emails on a domain name. These 4 records are important to understand because they are pretty much the base requirements for setting up any domain name. Now, when you type example.com in the browser tries to resolve this domain by querying the DNS server for the A record. However, when you try to send an email to testexample.com, so test@example.com, the mail server would query the DNS server to find the MX record. So if you want to look up the IP address of a domain from the command line, you can use a tool like nslookup, and then we can even go to something like nslookup.io, which is a website that does it for you. So if you don't want to do a command line, or if you don't have access to a command line, and maybe you're just running it from your phone or something, and you still want to find the DNS records for something, then you can actually go to nslookup.io, which is, it's literally what it looks like right here. So if we went to nslookup.io, you can tell I use that very frequently. That's the website. That's basically it. And then you just kind of go in here, and then you do, let's do example.com, and then run that. And then it says, look, this is the IPv4 address of example.com. This is the IPv6 address. Now check this out, right? So we talked about the IPv4 address and the IP address just changing regularly. So this is the current one that is happening as I record this. But when we go look at this thing, look at, actually, you know what? It is the same IP address. Okay, never mind. My bad. Their IP address did not change. I thought for a reason, one reason or another, I thought that their IP address would actually be dynamic and it would change. But I guess example.com, not that big of a deal. Google needs to rotate their IP address. Microsoft will need to rotate their IP address, so on and so forth. So NSLOOKUP does the same exact thing that NSLOOKUP.io does. And the command is basically NSLOOKUP, and then you put the domain name, and then that's pretty much it. And you can do www, you could do HTTPS // example.com. Essentially any way that you would refer to the domain name, so long as you have the end of it right, which is, I believe, the top level domain. As long as you have that right, then everything else will actually map to the place that it should, and then it'll get you the A record as well as the quad A record, which is in this particular case this. So this is an IPv6, this is IPv4. Now, it led to 4 packets, this example that we had right here. And in the terminal below, we can see that the first and third packets sent the DNS queries from the A and quad A records, respectively. The second and fourth packets show the DNS query responses. So the first and third is the queries that were sent out, and then this one and this one were the responses that came back to us. And so we can see that at the end of the response for this one, we see the IPv4, and at the end of the response for this one, the quad A record here, we see that this is the IPv6 address for example.com. So which DNS record type refers to IPv6? And that is 1, 2, 3, 4, the IPv4 or quad A. It's the quad A record that refers to IPv6. Which DNS record refers to the email server? That would be the MX record. And that's basically it. That's really all you need to know for now for the name records, the DNS records. So let's go into the WHOIS protocol. All right, so in order for these records, for the A, quad A, MX records, or other DNS records for the domain name, in order for those things to be set, somebody needs to have the authority to do that. And whoever registers a domain name is granted this power. So for example, you can get the valid DNS records for example.com if you are the one who registers that domain, meaning the person or the entity, I should say. The entity who actually registers that domain name is the person or the entity that would set the valid DNS records for that domain name. So for example, you can register any available domain name for 1 or more years. You need to pay the annual fee, and you're required to provide accurate contact information as the registrant. So your actual name, your phone number, the address, so on and so forth. This information is part of the data available via a WHOIS record and is available publicly unless you privatize that information. Although written in uppercase, WHOIS is not an acronym. It's pronounced WHOIS, right? However, don't worry if you want to register a domain without revealing your contact information. You can use one of the privacy services and hide all your information from the record. So you can actually be private. And in a lot of cases, a lot of people are, because you don't want the person who owns the domain name to get spammed all the time and get contacted by people all the time. It just becomes a really pain in the ass. For the most part, most WHOIS records are actually private records. Now, you can look up WHOIS records of any registered domain name using one of the online services via the command line tool WHOIS, available on Linux systems, among others. And as expected, a WHOIS record provides information about the entity that is registering the domain name, including the person's name or the company's name, the phone number, the email address, so on and so forth. And we can see this is kind of what it looks like. So that doesn't really do me much good. So let me kind of zoom in on this, see if I can get you a little bit better. Okay, so the registrar WHOIS server is based on, the corporate domains website. And let's see, the registrar itself is corporate domains. The contact email is domain abuse at CSC Global. This is their phone number. The registrant name is privatized, so therefore we don't see it. But this is essentially all the information about the actual person or the company. So the registrant could actually be a company. The admin most likely is going to be a person, but it could also be a company that manages the domain name. And then there's, their phone number, their fax number, their email address, so on and so forth. So all of this information falls under the WHOIS records of a given domain, right? So I think for the purpose of this exercise, it's actually been kind of marked out for us because maybe they want us to actually run it. So in this case, right, WHOIS, and then this is the .com that has been redacted for us. But this is the record. This is kind of what it looks like. So the registrar is GoDaddy. They registered their website with GoDaddy. This is the abusegodaddy.com, the phone number to GoDaddy to contact them. And then you have the registrant information that is private, right? Domain by proxy LLC, so on and so forth. So when was the x.com record created? Provide the answer in this format. When was the twitter.com record created? Provide the answer in that format. So for the purpose of this exercise, now we actually get to go and use our virtual machine on our attack box. So I got to zoom out of this a little bit and go to split view. And now I have access to my attack box here. And so we're just going to run the WHOIS domain here. So we're going to do WHOIS, and then we will do x.com. And then press enter. And we get a bunch of information here, and we need to go to the top to find the date, right? So they want year, month format, which is when was it created. So if we go here, we can say creation date is right here, 1993, 04, 02, and that will most likely be the date. So let's paste that, see if that's right. That is right. Now, when was twitter.com created? So same thing, WHOIS. Let me make sure it's actually typing in here. WHOIS twitter.com. And then we'll go in here and we'll scroll up, and then we'll get the creation date for the Twitter domain name. So where is that? Creation date 2000. So 01/21. It's interesting that x.com was actually older than twitter.com. I think obviously, like when the domain names became a thing, there were a lot of people that bought these like very short domain names. So probably a.com, b.com, like all these domain names, because they're so easy to remember. There were people that just made a killing from buying domain names at the very, very beginning, and they bought it for, you know, relatively cheap prices, and they were parking them. So it's called parking a domain name, and you basically just pay the annual fee for having it. And as time went by and these things became more and more popular, so let's see, how much did Elon Musk pay for x.com? And this is the, let's see, he bought it back from PayPal, so I guess PayPal owned it. He co-founded x.com in '99 and invested about $12 million in the company. He was the largest shareholder in the combined company. X merged with another company, also purchased Twitter for $44 billion and rebranded it as X. So I guess he's owned it essentially for the most part. But as we can see right here, that it was actually created in 1993. So this was not Elon Musk who originally bought it. He bought it from whoever the original creator, the registrant, was. So, you know, kind of random trivia. I don't know if that's going to be ever important to you, but that's kind of where my thoughts go usually. I'm like, oh, I wonder how much he paid for this. I wonder how much this whole thing cost, coming from 1993 to 1999, which is 6 years. It's like, I wonder how much that thing appreciated in 6 years, and whoever the original person was, like, I wonder how much he paid for that, or how much he made off of that, I guess I should say. Okay, so let's go to the HTTPS protocol. HTTPS is the protocol that is all about web browsing. So if we go here and we look at this at the very, very top right here, we can see that TryHackMe has HTTPS and then TryHackMe, right? So if I went to any website, dnslookup.com, click on that, click on it one more time, and then we can see that it is HTTPS. If we go to google.com, click on that, we can see that it is HTTPS. So HTTPS is the secure version of HTTP, which is the Hypertext Transfer Protocol, which is the protocol for web browsing. So anytime that you use your web browser, you are for the most part using HTTP and HTTPS protocols. Hypertext Transfer Protocol, the S in HTTPS stands for secure, And this protocol relies on TCP and defines how your web browser communicates with web servers. And some of the commands, which are the most common commands, are get, post, put, and delete. Get retrieves data. Post allows us to submit data. Put is used to create a new resource on the server and to update. So typically, I associate put with updating data and overwriting existing information. And then delete, obviously, as the name suggests, deletes a specific file or resource on the server. So when I make a request to google.com, right? So if I just go here and I do google.com, press enter, I now made a get request to get google.com, okay? When I go in here and I type in how much did Elon Musk did that, now I just did a post request where I sent a post. I sent something to Google and then they're now sending me data back, okay? And then, put and delete typically has to do with updating databases or something like that. So for the most part, your interaction with the websites that you go to has a lot to do with get and post requests for the most part. That's the majority of transactions or communications, conversations that happen with a web browser. But then when you update something or when you delete something, you delete a specified file or resource on the web server that you're accessing. So you delete one of your pictures from Facebook, you are sending a delete request to the Facebook server, and then they delete it from their servers. So HTTP commonly uses port 80 and HTTPS commonly uses port 443, and these are both TCP ports. And if you remember from the last video that we did, TCP is a connection-based protocol, meaning that we have to establish a solidified connection in order for TCP to actually work. UDP is a connection-less protocol, meaning it really doesn't give a damn whether or not a connection is made. It just sends data. It doesn't even verify whether or not the data was received or anything like that, right? So TCP is the more secure, the more reliable version of the two protocols between TCP and UDP. And then there are less commonly known ports such as 8080 and 8443. 8080 is typically reserved for actual web servers. So Apache, that's what I kind of connect 8080 to. And then 8443, again, is also, these are both also HTTP protocols, but usually they're used for specific web servers. When you're looking at HTTP and HTTPS, specifically in terms of web browsing, for the most part, this is more common, okay? It's commonly used. This is not a be-all and end-all. For the most part, it's 80 and 443 are reserved for HTTP and HTTPS respectively. Now, in this example, we're going to look at Firefox to browse the 10.10.163.136. Our browser fetches the web page and displays it perfectly. However, we are interested in what happens behind the scenes. So I'm guessing this is in the screenshot here, they're showing a different IP address that they access, but this is the IP address that was assigned to me when I launched this right here. So if I come out of this and I just go to the browser here, and also if you're connected via OpenVPN to the TryHackMe server, you can just do this from your own computer. I'm doing it from the AttackBox web browser because for me it's a little bit easier to actually access this way and to do the recording without having to worry about you seeing all the other stuff that's sitting on my computer. So this is the website, right? So we have the Art of Espresso that's loading, so on and so forth. But we're interested in what happens behind the scenes. So if we use Wireshark, we can examine the exchange between the Firefox browser and the web server more closely. The screenshot below from Wireshark shows the text sent by the browser in red and the web server response in blue. And we'll get into how to analyze Wireshark responses. I don't know if I have to do it for this particular room. If I do, then we'll just pull up Wireshark. But this is basically what the screenshot looks like if you actually go into Wireshark and look at the HTTP stream that is done for this website. So first there was a get request, right? So we sent a get requests to the domain name or the IP address, which was the one for the coffee website or whatever, the espresso website that we just got. So this whole thing is the request contents. And then there was a response from this web server saying, okay, the response code 200 means that your request went through, and it gave back what you wanted to do, and it gave you that response. And then this is all the contents of the response that you got. And so the title is The Art of Espresso. The body is, what is espresso? Espresso is a concentrated form of coffee, yada, yada, yada. So that is it, right? So you have the request, and then you have the response. And that's typically what it's like when you interact with a web server. Okay. Now, as we remember from networking concepts, we use the telnet client to connect to the web server running on 1010 at port 80. We had to send a couple of lines such and such to get the page that we wanted. On some servers, you might get the file without sending the host anything. So you can use this method to access any page that not just the default page, which is at the /. To get the file.html, you would send get file.html HTTP1 for instance, and then get file HTML might work depending on the web server in use. The approach is efficient for troubleshooting as you would be talking HTTP with the server, which is basically the language that the server requires. So now we're going to actually do that. So we're going to use telnet to access the file flag.html on this particular IP address. So what is the actual hidden flag? So in order for me to do that, and we want to do it with our command line here. So I'm going to clear my command line. And I'm literally just going to use the telnet command very simply. So it's telnet, and then you do the IP address, which is 1010, what is it, 163.136 is my, and then we're going to do it on port 80. So that's basically what we do right here. You just do that, and then you press enter, and then there you go. The connection is now made. Now what I need to do is I need to actually form my get request to the actual file that I'm looking for. So in this particular case, instead of doing get, just a root right here, and then doing HTTP1, I'm going to do get /flag HTML, and then do HTTP1, and then let's do that real quick. And the host could be anything, I guess. So I'm going to do a get, and it's all caps lock, and I'm going to do /flag.html, and then I'm going to do HTTP1, also in all caps, /1.1, and that's what that looks like. We press enter. And then the next line, we need to give it a host. So in this case, it's going to be host, and it could be anything, I guess. So I will do host, and I will do anything, and then press enter, and then one more enter to actually send it. And then we actually get our response. And so it worked because we actually did get the response here. So now what we're trying to do is find the flag. So the response was okay. So I actually got a good response from this thing. And then here's what it is. This is where the document actually starts, right? The header is hidden message, and the style of the body and everything is like that. And then the hidden text right here is the flag. So it's THM ... and then copy, and then you go here and you go there and you paste it, and there we go. So just to give you a quick review, just so you know what I entered to get this flag, okay? First, I did telnet. Let's zoom in. Hopefully, you can actually see this. So I did telnet, and then I did the IP address that I've been provided, and then I did 80 because I'm trying to connect to the HTTP port on 80. And then as long as this is up, as long as that port and that IP address is up, then you will get, okay, you were connected, and this is all good. All of this is just going to come automatically without you doing anything. As soon as you press enter on this command, the rest of this comes up immediately. The next one is these two commands that you have to enter. So the get request is the request that I want to send to the web server. So I want to pull this flag HTML file from the web server. And then I'm going to give it the language essentially that I'm communicating with it, which is HTTP /1.1, which is the version of HTTP that we're using to make this request. Okay. So essentially this could be get /file.html, anything.html, or just / by itself, meaning that I want to go into the root domain, the root partition of this web server, and then that would be followed by HTTP 1.1. So this part is going to be essentially, no matter what kind of request you make, that part is going to be at the end of it. This is the part that will change depending on what type of data you are trying to get from the server. So you type this, you press enter, and then on the very next line, you need to give it some kind of a host value. So in this case, we just did anything as the host, and then I pressed enter, which gave me this blank line, and I pressed enter again, and then it gave me the actual response from the web server. And then it tells me that this is the server type, and this is the date, and the content type, and then begins the actual data that I requested. So now it's the HTML document that I requested, and then it's going to say in the title that this is a hidden message, which makes me feel like I'm in the right place. This is the style of the rest of the website, of the rest of the document. So background is white, color is white, font family is Arial, sans serif, font size is 1 pixel, dot, 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 dot. So font being 1 pixel is like super small. So you can imagine that if it was actually on the web browser, most likely it's going to be missed because it's so small. But then, because we're looking at the source code here, it's not going to be very small over here. We're going to be able to see exactly what we want, which in this particular case was the flag. So we got it and it's all good and we did right and I'm happy about it. So I hope you got the same answer that I got. So now let's go to the transferring files using FTP. FTP, as the name implies, is the file transfer protocol, and it's the protocol that's used to transfer files. So it's very efficient for file transfer. When all the conditions are equal, it can achieve higher speeds than HTTP, which is basically designed to retrieve web pages. Now, the commands defined by FTP protocol are the user, the pass, which mean the username and the password. And then you have the RETR for retrieving, so it's used to download a file from the server. And then you have STOR to store or upload a file to the server, right? So RETR retrieves, STOR stores or uploads a file into the server. Now, the FTP port is port 21 by default, and it's conducted via another connection from the client to the server. This is not a secure port, okay? Just to kind of put this out there. This is not a secure version of the port that we're trying to use. And then as we go into the secure protocols for networking, we're going to talk about the secure version of FTP, which is actually SSH, or I think it's actually SFTP. I may be wrong. I know that port 22, which is secure shell, is a secure encrypted port. FTP is not an encrypted port. It could technically just be FTPS, File Transfer Protocol Secure, or SFTP, which is Secure File Transfer Protocol. In the terminal below, we executed the command FTP to connect to the server, and we used the username Anonymous to log in. We didn't provide any password. Issuing ls returned a list of files available for download. Typing ASCII switched to the ASCII mode as it is a text file, and then get the coffee.txt allowed us to retrieve the file. So FTP and then the IP address actually connected to it right here. And then the very first one is asking for the name, and so we did anonymous, press enter, please specify password, and then they just pressed enter without putting anything. And the password, the login was successful because I guess anonymous doesn't require a password. And then the remote username is Unix, the binary code is da 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 da. So all of this is just responses from the system. And then you have this command line. So the command line changes from this to FTP if you've actually successfully logged in, which allows you to then run commands like ls, because it is a Unix, see, remote system type is Unix. So since it's Unix, you know that ls will actually work, and then it's going to really, I guess, respond with the stuff that you got over here. So the directory send was actually okay, so it actually received the information that you wanted from it. And then we did type ASCII to change it to ASCII mode. And then we said get coffee.txt, and then local coffee.txt is how it was downloaded. Coffee.txt came from the location, entering passive mode, opening binary mode, warning 47, da 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 da, transfer complete. Bytes received in da 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 seconds, and then we just put quit, and then we exited out of it, and it's all good. Now, if you wanted to look at this on Wireshark to see what the actual transaction looked like, this is what it looks like. So let me see if I can zoom in for you a little bit. So we have the very first request, which was responded with a status code of 220, meaning that it was successful. And then the very next prompt that was sent was user anonymous. And then we got a please specify the password, and then we did nothing. So pass is empty here. And then another 230 response, which is a successful. Anything in the series of 200 is successful. So when you see 200 responses, that means everything was okay from the system and you got some kind of a successful message. So password was empty, login was successful. The system responded and gave us the type that we wanted, which is the Unix type. And I guess ls in this case would be L8 in this case. And then it went into passive mode. And then list is a command that you can make. Oh no, so you know what? ls is list right here. So my bad. So list is the command that we sent into it to actually get access to the contents of the directory, and then the directory responded, and then type A, meaning for switching to the ASCII mode, and then the system responded, and then entering passive mode, so on and so forth. So these, the ones that are in red, are the commands that was sent from the actual user. But what seems to be the case is that, so if we can try to track this down over here, so we did password, login successful, remote system type is Unix, using binary mode to transfer files. The very next command was ls. So there was no pasv to enter passive mode. And then it automatically just entered passive mode. And then here comes the directory listing. And then directory send was okay. And then we did type ASCII, and then it switched to ASCII mode. And then we did the get coffee, and then that happened, and then it entered passive mode by itself again. So it seemed like it happened as an automatic send to the system. So it was something that was automatically requested, and then the response was entering into passive mode. It wasn't anything that the user in this particular case actually did, because these commands, the red commands that we see here, they imply that the user actually entered PASV and then entered PASV over here. So that was not indeed the case. So now, use the FTP client, FTP on the attack box, access the server at this location, and retrieve flag.txt. What is the flag that was found? So we are just going to run the command as it is over here. Very, very simple. And I'm going to do exactly what they say to do. So we're going to do FTP, and then I'm going to do the domain name that I've been given, or the IP address, excuse me. So that's it, FTP, and then the IP address, press enter. And I'll zoom in on this for you a little bit. The name in this case is going to be what? Anonymous. Press enter. Password is just going to be empty, so I'm just going to press enter. And I am now logged in. So check this out. Very, very simple, right? Easy money. So FTP and then the IP address. Then the response came up to here. This was the response that I got, and I was supposed to send something in. So I just said the user is going to be anonymous. And then check this out, it's root permissions too. Isn't that interesting? So the user is going to be anonymous. Excellent. Please specify the password. And I didn't input anything. I just pressed enter, and then the login was successful. Now, this is not going to be the case in the real world, just so you know. This is a lab environment. They're trying to make it as easy for us as possible. In a lab environment, most likely you're not going to be able to log in as anonymous. And most like 99.999% of the time, you need to have somebody's actual username as well as the password, because you are not going to get into the FTP system that easily. Just giving you a heads up here. But, you know, I pressed enter with no password, and it said login successful, remote type is Unix, so using binary mode. Now, if it's Unix, if I do print working directory, it should say that this is my current directory. I'm inside the root directory. If I do ls, it should just list all the stuff that is in the directory, which in this particular case is the coffee file, the flag file, and the T file. So now the next command that we had over here was to just switch to ASCII mode. So we'll just do type ASCII, press enter, and now we've switched to ASCII mode. Now I can do get flag.txt, press enter, and file transfer is complete as we get over here, right? So I did ls, which you saw me do. It's all good. It listed the contents of the directory, type ASCII, and it switched it to ASCII mode. And then I did get flag.txt, and then it made the requests, and then finally it said the transfer has been complete. So now I should have a flag.txt file. I don't know where it is, but seems to be that I have it. So now that we have that, we can actually quit out of this mofo. Boom. And then that is goodbye. So it's all good. So it downloaded to wherever I am currently logged into on my terminal. So if I do print working directory, it's inside of the root directory. If I do ls, I should see that there is actually a flag file inside of my root directory. So I can now simply do cat for concatenate flag.txt, and there is my flag, baby. I love when these exercises work as smoothly as they do. Then again, these are very, very simple exercises. So hopefully you were able to follow along with that one as well, and you were able to get the response that I just got. So now let's go into the SMTP protocol. So just like browsing the web and downloading files, sending email also has its own protocol, and that is the Simple Mail Transfer Protocol, which is SMTP, which defines how a mail client talks with a mail server and how a mail server talks with another mail server. So the analogy for SMTP is when you go to the local post office to send a package, you greet the employee, you tell them where you want to send your package and provide the sender's information before handing them the package. Depending on the country that you are in, you might be asked to show the ID. This process is not very different from SMTP. Now let's present some of the commands that are used by the mail client when it transfers an email to the server. So hello, or EHLO, initiates the session. And this is, I believe, an actual O, so it's not a 0. And then we have mail from specifies the sender's email address. Receipt to, RCPT2, specifies the recipient's email address. And then data indicates the client will be sending the content of the email message. And then this dot is sent by a line to itself to indicate the end of the whatever. I guess the sentence is not finished. That's funny. Okay. So terminal shows an example of an email sent via the telnet protocol. So if you did not watch our previous video, you can use telnet on a variety of different port numbers. So we actually did telnet on port 80, but now we can do telnet on port 25, which is the SMTP, the Simple Mail Transfer Protocol server. So we can use it so that we can actually send an email. Now, once it is connected, then it's going to just say, hey, you know what? Hello, client THM, right? And then mail from this person, and then receipt to this person, and then data. And then it says enter message ending with a dot on a line by itself. So from user to user, telnet email is going to be subject, and it's going to be say, hello, I am using telnet to send you an email, and then dot by itself to imply that we are ending the email on a line by itself. And then that's it. And we should get an OK. And then we can do quit so that you can actually close your connection. And that's basically it. So sending an email using telnet is quite cumbersome. However, it helps you better understand the commands that your email client uses under the hood. Wireshark shows us what's actually happening. So we go here, and the first request to actually connect to telnet was successful. And then so we sent a hello client.thm. And so we were initiating the conversation to the client.thm server. And then the response was, hello, everything's all good. Then we said we want to mail from this email address. We want to send it to this email address. And then all of these things was okay, okay, accepted. Now the data, you press data, and then it says, all right, enter the message ending with this. So you press data, and then you press enter. And it says enter the message ending with yada, yada, yada. And then you said from this person to this person, subject is going to be this person or this subject. And then hello, I am using the telnet to send you an email, and then dot by itself at the very end on its own line is implying that that's the end of the email, and it's going to be okay, and then quit, and we're good. So that's basically what that looks like. So now that we've actually covered it, let's send an email. So which SMTP command indicates that the client will start the contents of the email message, and that would be data. And when does the email client, or what does the email client send to indicate that the message has been fully entered, and that is the dot on a single line? I mean, I guess we don't have to send an email. I'm kind of disappointed. I was hoping that we can actually send an email, but yeah, I'm just gonna leave it alone. I'm not gonna go down the rabbit hole because I always end up going down the rabbit hole. But the instructions are very, very clear, and it makes it even more clear when you're looking at the Wireshark output. So up until, you get the connection via telnet, first thing you do HELO, and then the name of the actual server that you want to communicate with, or you want to use to send your email. And then it's going to say, okay, you're all good. Now we're going to mail from, that would be the next command. So mail from, all in caps, and then you do a colon. And then inside these brackets right here, you would put the email address from that you want to send from. And it's obviously sitting on the client THM that you've just connected to. And it's going to say, all right, cool. and you say RCPT2 colon, inside the brackets, you would do the name of the email that you're sending to, and it says, all right, that's cool too. And then you type data, all caps, press enter, and it says, all right, cool, enter the message ending with whatever by itself. And then this is all being typed by us. So from user client to this person, subject, telnet email address. And then you type your actual body of your email. And then when you're done, however long the body is, the very last line needs to be a dot by itself. And then you press enter and it says, okay, all good. And then it's sent it, so you're all good. And then now you can just type quit so that we can close the connection with the mail server. And that's basically it. So now let's talk about the POP3 server, or the POP3 protocol that is for receiving email. The post office protocol version 3, which is POP3, is what we use to check our received email. So you receive an email and you want to download it to your local mail client, and this allows you to do that. So it allows the client to communicate with a mail server and retrieve the email messages on there. Without going into all the details, an email client sends its messages by relying on SMTP and retrieves them by using Post Office Protocol 3. SMTP is similar to handing your envelope or package to the post office. POP3 is similar to checking your mailbox for new letters or packages. So very simple, right? SMTP, you drop it off at the post office. POP3 is your actual mailbox in front of your house. Some common POP3 commands are user for the user, pass for the password, stat to request the number of messages and the total size that are currently in your inbox, list lists all of the messages and their sizes. So stat just says this is the number of messages and how big they are. List actually lists the messages and their individual sizes, and then you can retrieve the message by its number, right? So retrieving the specified message, DELE deletes the number, so marks the message for deletion, and then quit ends the session so that you can get out of it. And then of course you can use telnet to do the same thing. POP3 sits on the 110 port, so SMTP was on port 25, POP3 is on port 110. So telnet, the IP address 110, you connect and everything's all good. Okay, so far everything's all good. This is going to be the response that you get by just doing telnet IP and then the port number. And then we do authorization, okay, plain, dot, all good, user, strategos, I guess, whatever. And it's going to say, okay, password is whatever, I guess. And then you press logged in, you press the password, you press enter, and it says, okay, you're logged in. Then you do stat, and it says 3, and then the size. So there's 3 messages, and the size is 1,264 bytes, I guess. And then we have list, and then so it says, okay, 3 messages, this one is this size, this one is this size, so on and so forth. And you say retrieve number 3, so retrieving this email, and it says okay, and here we go. So this is where it's coming from, this is where it's to, which is strategos or strategos or whatever, and then it says received from this IP address, by example, with SMTP, envelope from user client, this is the ID, this is da-da-da-da, this is the actual body. So this is literally the email that we sent in the previous exercise that we did, or that they showed us using SMTP. It's the same exact email, but now since it's been sent to strategos or strategos, whatever, this is the body of the email that they got. And so now, cool, all right, quit, and it's logging out. So he didn't even delete the email, he just read the email, and I was like, all right, cool, all right, we're good. So someone capturing their network packets would be able to intercept the exchange traffic as per previous Wireshark captures. The command in red are sent by the client, and the lines in blue are the servers. So first we connected, and then it says auth to authenticate, and it says okay, plain text, all that stuff. User is going to be strategos. Okay, password is actually entered in here. So there was a password that was entered because it is a mail server after all. And it says, all right, cool, you're logged in. And it says stat, show me my emails. And it's like, here are the email count and the size. Okay, list them. And here's what it did. And then it said retrieve number 3. And then this is the response from the server. And then he said quit. And he bounced. And that was it. Very, very simple. So connecting, all right, cool. Now we can actually connect. So connecting to the POP3 server requires authentication. Use the following login credentials when needed. Now look at the traffic exchange. What is the name of the POP3 server running on the remote server? So look at this. What is the name of the POP3 server running on the remote server? I would say it's xClient, right? Or is it Dovecot? Okay, Dovecot Ubuntu ready. So what is the name of the server that is available? So let me just double check and make sure that I'm good. Okay, yeah, it is Dovecot. So Dovecot was the correct answer, which is right here. So it says Dovecot is ready. That's the name of the mail server. That's in our traffic capture. Now use Telnet to connect to POP3, and then what is the flag contained in the fourth message? So we are gonna go out here one more time. We're gonna clear this bad boy. We're gonna do Telnet, and then we're going to connect to the same IP, but we're doing it on port 110. I'm just gonna press enter. I totally misspelled Telnet. So Telnet, there we go. 10, and then for, my God, what am I doing here? What am I doing? Telnet, and then we're going to do 10, 163, 136, port 110. Very good. All right, cool. Now we are actually ready. So it says what? Connected to such and such. Okay, client is ready. So what is the next thing that we got to do? We got to send an authentication request, right? So that's the first thing that it said. Client is ready. So the next thing that we're going to do in all caps, we're going to do, let me make sure I'm all caps, auth. Press enter. All right, cool. You're ready. Now user is going to be, who's the user? Linda, right? Yeah, Linda. So user is Linda. Linda, listen. Very good. User is okay. Pass, just like that, is going to be PA $123. Enter. There we go. We are now officially logged in. So I can first just do this, right? Stat, and it's going to say, all right, there are 4 messages. I can do list, and then it's going to give me my list of 4 messages. So here we go, right? Just to show you what's going on here. So the client is ready. I did auth, and then it said okay, and it gave me these 3 lines, and it says user Linda, so capitalized user, and then Linda is the actual username, and then pass, and then that's the actual password, and now I'm logged in. The first command I gave it was stat. It said you have 4 messages. Then I said list, and then it gave me my list of messages. So now I'm going to do RETR, and I'm going to say 4, press enter, and now here's the email, and there we got it. So RETR4, okay, cool. This is the da-da-da-da-da, and it's from the user client Linda at server. This is the flag. There's my flag, baby. Copy my flag, go over here, paste the flag, and we are good. All right, so now let's talk about IMAP, and we are officially wrapped with this room. POP3 is enough when working from one device, maybe your favorite email client on your desktop. However, what if you want to check your email from your office desktop computer and from your laptop or even your smartphone? In this scenario, you need a protocol that allows synchronization of messages instead of deleting a message after retrieving it. So for example, what I just did will delete email number 4, and I haven't actually quitted from this thing. So if I go over here, and let's see if we do list one more time on this thing, if it'll still have, oh, it still has all of my messages. So if I quit, let's quit and then go back and do another connection to the telnet, and it's going to say it's ready. So I'm going to do auth, and then it says unknown command. So why am I not ready? What did I do? Error unknown command? What? Quit. Maybe I did something wrong. So connection closed by foreign host. So connected, oh, it's because I had the extra backslash. So there you go, that's all good. So now I want to authenticate, press enter, very good. User is going to be Linda, and then I'm going to do pass of PA $123, press enter. And now if we do list, oh, I still have 4. So I guess it doesn't automatically just delete the emails. So that is, okay, never mind. So I was mistaken. So that's my bad. But I mean, based on the instructions, it kind of leads you to believe that it will allow synchronization instead of deleting a message after retrieving it. You see what I'm saying? So one solution to maintaining a synchronized mailbox across multiple devices, Internet Message Access Protocol, IMAP, Message Access Protocol. So IMAP allows synchronizing the read, moved, and deleted messages. Let me say that one more time because my accent just destroyed it. IMAP allows synchronizing read, moved, and deleted messages. IMAP is quite convenient when you check your email via multiple clients. Unlike POP3, which tends to minimize server storage as email is downloaded and deleted from the remote server, IMAP tends to use more storage as email is kept on the server and synchronized across the mail clients, right? So POP3 tends to minimize server usage because the mail is downloaded and deleted from the remote server. The IMAP tends to use more storage because the mail is kept on the server instead of being downloaded, and it's synchronized across the mail clients. The protocol commands are more complicated than POP3. These are the list. So we have login, and then you give it the username and the password, and it authenticates you. Then you say select the mailbox. So it selects the mailbox folder that you want to work with. And then you say fetch the mail number and the data item name. So for example, fetch number 3 body, for example, right? So you want to retrieve the body of email number 3, and it fetches message number 3, header and body. And then you say move the sequence set to the mailbox. So it moves the specified messages to another mailbox, and then copy the sequence set and then the data item name. So copies the specified messages to another mailbox and then log out. So this is definitely much more complicated than what we dealt with SMTP as well as POP3. So knowing that the IMAP server listens on TCP port 143 by default, we will use Telnet to connect to it and then fetch the messages. So Telnet IP address port 143. It says all good, you got your connection, everything's all good. So login Strategos. That's the first thing. Login Strategos. Now, we did that and it said okay. So I guess the password is being hidden from us in this case. And then it says select inbox. So it says okay, flagged or whatever. These are the flags, meaning what you can select as the types of messages that are available for you. And then so these are the flags that are available. So it says okay, 4 exists, right? Is that what's the next thing? So fetch, he didn't even do or maybe that's the flags permitted. I don't think this was the, let's see, what's the next thing? Let's go to this. This is actually more useful. So login, Strategos, and the password. And I said, okay, so yeah, these are all the responses from the server. So this was, none of these things was something that I would have actually seen. So then the next one would have been select inbox. So the next command that he did was the actual select inbox command, which is right here. So login Strategos and then select inbox. After he did select inbox, these are all of the responses that could potentially exist. So 4 exist and 0 recent. All of these things is coming from the server, all of this blue. And then he says fetch 3 body. So fetching 3, which is email number 3, I guess, and the body of it. And then it retrieved the body of that email. And then it said, okay, log out. So for the most part, that was fairly simple if we just know what we are looking at here. So this is what the user sent. This is what the user sent. And all of this was a response from the server. Okay, so that's very important to understand. So do we have an exercise? It says what IMAP command retrieves the 4th email message? So it would be fetch, right? So fetch 4, and then we do body like that, and that's what would receive it. But the most complicated part about this is knowing the difference between, at least when you're analyzing something like this that's not color coded. I guess it's everything that starts with kind of an asterisk is the request or the response, excuse me, from the server, and then the stuff that's also misleading because this is starting with an A. So, and this is starting with a B, and then these are all asterisks, and then this is starting with a B. So that's not a good enough system to know which one is the server and which one is the client. So the best way that I could analyze this just as a first timer kind of looking at this would be the ones in the blue obviously are the server. This is what the client sent. So this was login, their username and the password. And then they were able to retrieve some kind of response, and it started with, okay, everything's all good, da 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 da. And it's like, all right, cool, select the inbox. And then so the response from the server was, all right, I'm selecting your inbox. These are all the things that you can check out. And then he said, all right, fetch number 3. So 4 exists, meaning there are 4 emails that exist, right? 0 of them are recent, and then unseen is 2. UID validity, UIDs are valid, UID next 5, predicted next UID, so on and so forth. So these are the key elements of this response from the server. There are 4 that exist, 0 of them are recent, and it goes, okay, so fetch the number 3, fetch number 3's body, And then so it fetches the header as well as the body. So this is all header, and then this is the body right here. Hello, I'm using Telnet to send you an email. Okay, cool. And then that's it, right? And then you do log out and you get out of the system. So we don't have an exercise for this one because they didn't give us a username and password that we can use, but you can kind of, hopefully you can wrap your head around the process of using IMAP to retrieve email. And with that being said, we're just going to talk about our conclusion, give you a couple of final notes, and we will wrap this video. So in the last room, we discussed the Telnet protocol, and we used a few of the ports that were definitely not on here. In this room, we actually used the other fundamental protocols, and a lot of them were done with Telnet. So we actually accessed an HTTP server, FTP, SMTP, POP3, and IMAP. We were shown at the very least how to do it, and in a few of them we did ourselves. And we did that with the Telnet protocol. We just did it on different ports. Now, with the protocols that we covered, we now have a better understanding of how domain names are resolved, how web pages are served, how email is sent and received. And another primary purpose of this room is to give you a good understanding of how a protocol functions behind the graphical interfaces, which is exactly what we did, right? So the protocol itself was technically Telnet. Technically, that was a protocol. We just used different port numbers to be able to access the various services that you can access using Telnet. Telnet is the protocol. The transport layer is that it was using the transport, the TCP. And then we have the port 23, which is the default for Telnet. But then you were also able to use the HTTP port using Telnet. We were able to use the FTP port using Telnet, right? And then we were able to see some examples of the SMTP, POP3, and the IMAP as well using the Telnet protocol. So that's what's important to understand, is that for the most part, the FTP one, actually, I think we did FTP, and then we used FTP and then the IP address. But SMTP, POP3, and IMAP, as well as I think it was the ones that we did in the last video, they were all using Telnet and then the IP address, and then we just gave it a port number. So these are essentially the protocols. These are some of the key protocols, right? The core networking protocols, so to speak, that are used in networking as a topic, as a concept. And then in the next video, we're going to talk about the secure versions of some of these very important protocols and how we can access them. HTTPS is technically a secure protocol, so that really won't count, but I think we'll probably talk about it as well. But I think we're going to be talking about secure shell, for example, or secure copy, and file transfer protocol secured, and so on and so forth. So there are secure versions of all of these protocols, and it's very, very important to know that in the context of system administration, in the context of cybersecurity, you would not use FTP because it is not encrypted and it is not the secure version of that protocol or that port. Therefore, it won't be encrypted, and people can basically very easily capture the data that's being transferred, communicated back and forth on that port number. So it's just really, really important to understand. So that is basically it for this, and we are officially wrapped. So let me just give you a couple of notes, and we will wrap it up. All right, so if you found this video useful, and if you want to get future videos on the CySec101 pathway, and of course the big video that's going to be coming up in the next couple of weeks, which is the Security Plus training series that's coming out, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that those videos come out. And of course, drop a comment. I do very much love hearing from people inside of the comment section. If you just want to say hi, if you just want to say thanks, all of that stuff is super welcome. If you have a question, please drop your questions. If you need something clarified, please let me know. There was actually a guy earlier today that asked about some of the new rooms that came from TryHackMe, which I'm going to be creating because he asked for it. And I'm like, okay, of course, if I can get anything that will help you guys in your journey of cybersecurity, I would be more than happy to do it. So this is why I do these things. So please drop a comment. Let me know if you have any questions and if there's anything that you need from me. And if I can, I will. If I can't, I'll politely say, I'm sorry, I can't, or at least not right now, whatever, right? So like, subscribe, turn on notification bell, drop a comment, say hi, and just let me know that you're actually in the community. It would mean a lot to hear from you. And then there's the Hackaholics Anonymous membership community, which is the premier YouTube community for security professionals and hackers. And it has 4 tiers of perks. And it starts with the cyber supporter at $4.99, and they get their Discord server as well as access to me directly and all of our advanced members. They get early access to content. And then we have the advanced members that get Python automations every single month. They get live streams every single month with me. They get their own Discord servers. They get exclusive content, exclusive downloads, like all of the notes and the practice questions and the practice exams that's going to be coming out with the Security Plus course that's coming out in the next couple of weeks. So if you want to join Hackaholics Anonymous, you can do so in the link in the description below. You can go to our homepage and click the join button, or you can simply go to youtube.com/@HankHacksHackers/join, and you'll be able to join the best community for security professionals and hackers. And I really look forward to seeing you in our Discord chats and inside of the community tab for the Hackaholics Anonymous members. And if nothing else, then I would very much love to see you in the comment section in our YouTube community over here. So this is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. The new year is right around the corner, baby. So I hope you're getting all your ducks in a row and getting ready for 2025. And I will see you in the next video.